Here we continue with compound inequalities. So sometimes inequalities are going to look like this, where you have two sides. So that means that you have this 2x minus 1 bounded between a -5 and a 7. So the thing that you want to do is still isolate this x, but I want to get rid of this minus 1. So I have to add 1. But now where am I going to add 1? Since there's two sides, I'm going to add it to all of the sides. Okay, so if I add it to one side, I also have to do it to the other. So now this is going to go away. I'm going to left with 2x less than 8. And then over here, a less than or equal to -5 plus 1 is going to give me a -4. I'm going to divide by the 2 to both sides. Divide by 2. X is between -2 and 4. Okay, this is my solution. Okay, so what you end up getting is that x is between two different numbers. So if I were to look at a number line, x is between -2 and +4. -2 is included, so I'm going to write a closed circle. 4 is not included, so it's going to be an open circle, and it's going to be everything in between. So how do I write this in interval notation? It will be between bracket -2 all the way to 4 parentheses. Okay, and that's all there is to it. Okay, so let's try another problem. So let's say we wanted to do -5 less than or equal to 3x minus 2 less than or equal to 4. Okay, so we want to figure out what value of x will solve this inequality. So first I'm going to add 2 to both sides. Okay, so this is going to go away. I'm left with 3x is, now you have a less than or equal to sign here. -5 plus 2 is going to give me a -3. Over here, I'm going to get a +6. Divide by 3, divide by 3, and divide by 3. Okay, so x is going to be between -1 and +2. Okay, so if I go ahead and write it in a number line, here is -1, it's included. Here is 2, also included. Everything in between it is the solution. So the answer will be from -1 all the way to 2. Okay, it's very, very straightforward. Okay, now let's do one last one. Okay, so here's my example. It's going to be 7 is less than or equal to -2 over 3x plus 1 less than or equal to, let's say it's 10. Okay, so we're going to do the same exact thing. We're going to move the 1 over, -1 to every single side. Okay, this is going to go away. I'm going to be left with a -2/3 x in the middle. Now I have a 6 here, and I have a 9 here. Okay, now what we want to do is get rid of this 3 on the denominator. Okay, so since the 3 is on the denominator, I'm going to multiply every single thing by 3. This gets a 3, this gets a 3, and this gets a 3. So here I'm going to have 18 less than or equal to, the 3's will cancel out here, and all I'm left with is with this -2x. And then I'm going to get a 27 over here. Okay, last thing, I'm going to divide by this -2, but since I just divided by a negative, I have to flip the sign. So this is going to be now -9. This is now going to be -27 over 2, and just leave it as a fraction. Okay, now because I don't like this greater than signs, it's much easier to read it. So I'm going to kind of like flip-flop it. So I'm going to write the -27 over 2 here. Then it's going to be less than or equal to x less than or equal to -9. So all I just did was I just kind of like flipped it over. So now this one goes here. I flip the sign over, x goes here, and then the 9 goes there. Okay, so my answer is going to be between -27 over 2 all the way until -9, and they're both included. Okay, that's all there is to these types of problems. They're really not that difficult. Just beware with the signs and make sure that you're adding and dividing or whatever you're doing to every single term.